In this tutorial, I want to give an example of how to complete a problem when we have three planes that meet along a common line. So what we would do in the example we've got here is we'd put the three equations into our calculator. We would then try and solve it, and we'd get a maths error because there isn't a unique solution. The next thing we need to do then is to check to see if there are any parallel planes. So what I like to do is to try and make one of the variables have the same coefficient in each equation, and then check to see if the ratios of those coefficients of each equation are the same for any pair. If they are, those planes are parallel. So the first thing I'm going to do is I'm going to multiply this first equation by 4, because I want to make the same number of y's, and that's going to give me 12x plus 4y minus 4z equals 40. And then I'm going to multiply the second equation by 4 as well, and that's going to give me 4x plus 4y plus 8z equals 60. And we can see straight away that the coefficients of the variables, the ratio of those coefficients, are not the same in any case. We don't have any parallel planes. So what we can say there is that the ratios of coefficients of the equations are not the same for any pair, therefore there are no parallel planes, therefore the solution is either going to be planes that meet along a common line or planes which form a triangular prism. Another thing that we can say there is that the intersection of two planes form a line which is parallel to the third. Okay, I've tidied things up a little bit for you there. So to decide which one of these two situations is correct, what we do is we try and solve the problem, and if we end up with an inconsistency, it's the triangular prism. If we end up with a consistent result, although not very helpful result, then we know that it's the planes meeting along a common line. So the first thing I'm going to do is relabel these equations as well. Let's call that one 4 and call that one 5. So I'm going to eliminate the y from the equation. So the first thing I'm going to do is I'm going to do equation 3 minus equation 5. I'm at the moment, I'm deciding I'm going to deal with these ones because they've all got the same number of y's. So 3 take away 5 is going to give me 2x, the y's are going to cancel, minus 3z equals minus 5. Do note I cannot cancel this down anymore by dividing by a common factor. And then what I'm going to do is I'm going to do equation 4 minus equation 3. So that's going to be 12x take away 6x, which is 6x. The y's are going to cancel. Minus 4z minus 5z is minus 9z. And then I'm going to have 40 take away 55, which is minus 15. This one does cancel down, and it cancels down by dividing by 3 to give me 2x minus 3z equals minus 5. Let's call that equation 6 and equation 7. So now do equation 6 minus equation 7 and we get 0 equals 0. That is consistent, it just isn't very helpful. So that would imply the planes, meet along a common line. The next thing we need to do is to find out the equation of that line. So I've tidied things up again. We would definitely want the wording and the working out we've done before. I just want to show now how we can find the equation of that common line. Now the important things we've got here is that simplified equation that we got previously. What I'm going to do is I'm going to rearrange this so it's either x equals or z equals. It doesn't matter which. So here's the first thing. So we're going to say 2x equals 3z minus 5. Divide both sides by 2, and we've got x equals 3z minus 5 over 2. Now all I'm going to do is substitute that into one of the other equations to eliminate x from that equation. And the obvious choice to go for is this second equation. So that's going to give me 3z minus 5 over 2 plus y plus 2z equals 15. Okay, so we're going to simplify this equation. So I'm going to multiply by 2. So 3z minus 5 plus 2y plus 4z equals 30. So that's going to give me 2y plus 7z equals 35. Okay, so I've now got my second equation that's only got two variables in. So that's the first step. So now I say, which variable do they both have? And they've both got z. So I'm going to rearrange each equation so that it's z equals, so z's the subject. So this equation here becomes, if I take the 3z to one side, the 5 to the other and divide by 3, so that's going to be z equals 2, let's do that, 2x plus 5 over 3, and this equation becomes z equals 35 minus 2y over 7. So the equation of the line is simply z equals, so write down one side, so I'm going to put this side down, 2x plus 5 over 3, but it also equals this one here if I want it in terms of y, which is 35 minus 2y over 7. So the equation of a line in 3 dimensions actually has 3 parts. The next thing I want to do is just list the steps that we had to go through to solve this problem or to complete this problem. Okay, so step 1 was to try and solve it with the calculator and basically show that there is no unique solution. Okay, fine. Step 2 was to look at the ratios of the coefficients to show that there are no parallel planes. Step 3 was to define, and this will always be the same, the two possible geometric representations. And step 4 was to decide which, and that's either going to be if it's consistent or not. Step 5 would be eliminate a variable. It's a bit confusing this bit, but eliminate a variable from the first equation. 6, make the common variable the subject in each equation. Step 7 is to write the equation in 3 parts. So I hope you found this tutorial helpful. I've written it out a bit clearer for you here, keeping it in field with Winfield.